Hello and welcome to Cognito Key. Every single time you connect to Wi-Fi, there's this tiny digital detective that gets to work, solving a mystery that happens millions of times a second. Today, we're going to pull back the curtain and see exactly what it's up to. So it all comes down to this really interesting question. Every single device on your network, your phone, your laptop, even your smart fridge, has two totally different addresses. How on earth does it know which one to use when it wants to send something? And this, my friends, is what we call the two-address problem. It's this fundamental challenge of figuring out location versus identity on any network. See, on one side, you have the IP address. Think of this as your device's current location. It's logical, it's changeable, just like your home address. If you take your laptop to a coffee shop, you got a new IP address. Simple. But then, on the other side, you have the MAC address. This is the device's true identity. It's a physical address that's burned right into the hardware at the factory, kind of like a unique serial number. It never, ever changes. So, here's the real puzzle. To actually get a message delivered to a specific device on your local network, your computer has to somehow translate that temporary IP address into the permanent MAC address. It needs to turn the where into the who. But how does it do that? Well, this is where our hero of the story comes in. Let me introduce you to ARP, the Address Resolution Protocol. You can think of it as the network's very own detective, always on the case, finding the right device for the job. At its heart, ARP is basically just a translator. Its entire job is to take the one thing it knows, that temporary IP address, and use it to find the one thing it needs, the device's permanent MAC address, so it can actually deliver the data. And to get a little technical for a moment, ARP's very specific mission is to map a 32-bit IPv4 address to a 48-bit MAC address. It's the essential bridge between these two very different network languages. So how does our little detective actually conduct its investigation? Well, it uses a really simple but super effective process of a request and a reply. Okay, imagine it like this. First, the sending device checks its own notes to see if it already knows the MAC address. If it doesn't find it, it basically shouts out to the entire network. It broadcasts an ARP request saying, hey, who here has this IP address? Then, the one device that has that IP address recognizes the call. And finally, and this is the really clever part, it doesn't shout back to everyone. It sends a private, direct reply called a unicast reply straight back to the sender, saying, that's me, and here's my MAC address. Just think about that for a second. The request is a public shout for everyone to hear, but the reply is a private whisper. This is an incredibly efficient design that stops the network from getting totally flooded with unnecessary chatter. It's really quite brilliant. But our detective is pretty versatile. You see, ARP isn't just a one-trick pony. It actually has several different variations or flavors for different networking situations. For example, there's proxy ARP, where a router acts like a helpful receptionist, answering requests on behalf of other devices. Then you have gratuitous ARP, where a device basically announces itself to the whole network to make sure there are no address conflicts. And, just like their names suggest, reverse and inverse ARP do the exact opposite. They start with a MAC address to find an IP. But, just like in any good detective story, there's a dark twist. What happens when our trusted detective is compromised and starts to lie? Well, this is where we run into a really serious security threat. This is called ARP spoofing, or sometimes ARP poisoning. It's a nasty cyber attack where a bad actor sends out fake ARP replies. They essentially lie to the network, tricking it into thinking that their MAC address belongs to a legitimate device, like your router. And the consequences of this can be really severe. An attacker can start intercepting all your private data, letting them perform what's called a man-in-the-middle attack, where they can see everything you send and receive. This is such a powerful attack because it exploits the very trust that ARP was built on. You have to remember, ARP was designed in an era of smaller, more trusted networks, so it has no built-in way to check if a reply is legitimate or if it's a lie. All right, I know that was a lot of information, so let's just boil it all down to the absolute essentials. Here is your quick cheat sheet for everything we've just covered about our network detective, ARP. So, the most important things to remember are these. ARP's main job is to find a MAC address from an IP address. It's mapping a 32-bit IP to a 48-bit MAC. And the big one, the ARP request is a broadcast shouted to everyone, while the ARP reply is a unicast whispered right back to the sender. ARP is just one of so many of these invisible heroes working silently in the background every day. It really makes you wonder, doesn't it? What other amazing, invisible protocols are out there working tirelessly right now to make all your daily scrolling and streaming possible? If you enjoyed uncovering this little secret of the digital world with us, please help others find it with a like and a share. And for more explainers just like this one, make sure you subscribe to Cognito Key. Thanks so much for watching.